Okay, this is word problem number 7 on page 315, and what's described is we have a walkway that surrounds a swimming pool, and the walkway is a uniform width, so it's x, across this way, and it's x across everywhere you look. So we're told that the pool that's on the inside is 8 meters wide by 10 meters long, so that's 8 by 10. So that area is 80 square meters. And then we're told this walkway, the part that's like the frame around the outside, has an area of 72. So altogether, the total area is 80 plus 72, or 152 square meters. So anyway, what we have to do is be able to say, can we express the area of both of these things using the outside dimensions? So I have a look and I say, well, if I know the length from here to here, and I multiply it by the width from here to here, that should give me the total area of 152. So across here, if this length of the pool is 10, and I've got x meters of walkway on either side, then this outside dimension is 10 plus 2x. And on this one, if it's 8 feet from here to here, and I've got x going this way and x going this way, then this dimension is 8 plus 2x. So there's my equation. The length of 10 plus 2x times the width of the whole outer deck of 8 plus 2x should be equal to the total interior area that includes the walkway and the pool of 152 square meters. So multiplying this out, we get 80 plus 20x plus 16x, so plus 4x squared equals 152. So 4x squared plus 36x. If I subtract 152 from both sides, I'll get negative 72 on the left, set equal to 0. So before I jump in and start trying to use quadratic formula or completing the square, I'm going to cut this down. I have a common factor of 4 inside each term. So 4x squared plus 9x minus, let's see, 4 goes into 7 one time with 3 left over. 4 goes into 32 8 times. So here I am. So because it's an equation, you could, divide out the 4, because you'll still have a 0 on the right. And then we're going to factor that, x squared plus 9x minus 18. And we can't. It doesn't factor. The factors of 18, 3 and 6, you're not going to get a positive 9, and I can't get a negative 18 with those. So it's time to use quadratic formula. So in this case, a is the 1, the coefficient to the squared term. B is 9, and C is negative 18. So quadratic formula, x equals the opposite of 9 plus or minus the square root of 9 squared minus 4 times a, which is 1, times c, which is negative 18, all over 2 times a, which is 1. So this is negative 9 plus or minus the square root of. So inside here, 9 squared is 81, minus a negative, so plus 4 times 18. 4 tens is 40, 4 eights is 32, so that's 72. So this is 153, square root of 153, all over 2. So that's 2 answers. That's negative 9, or 2 roots, plus the square root of 153 over 2, all over 2. And it's also negative 9 minus the square root of 153, all over 2. So decimal approximations of these, this is, I'm going to punch this into a calculator. Let's see, what do we get? We get 1.68, if I round to the nearest hundredth, meters. So that would say that this width of this deck is 1.68 meters. Let's see, somewhere else I have written down the negative value that I get on this. Well, anyway, your solution, your other solution, well, let's just do it now. -9 minus the square root of 153, enter, divided by 2, is going to be a negative, right? Negative 10.68. And obviously, the width of this deck can't be a negative. So, this one gets rejected. It's not feasible. It's not in the feasible domain. Not possible. And so the width of the deck is 1.68 meters. That's rounded to the nearest hundredth. And that is it.